In this section, we use the law of cosines to solve for the missing parts in some triangles. For our first problem, we have solve triangle ABC if side A is 410 meters, side C is 340 meters, and angle B is 151.5 degrees. So you can see I've drawn a little picture right here of the situation. Angle B is included between sides A and side C. So I can use the law of cosines here to solve for side B. And here's the law of cosines. B squared is equal to A squared plus C squared minus 2AC cosine of angle B. So according to the law of cosines, this is going to be the formula I'm going to use. Whatever side I have over here, it's the other two sides right here, and then the angle that goes here is the angle that's opposite this side. So let's fill in these numbers for this situation. So I have A squared, which is going to be 410 squared plus 340 squared minus 2 times 410 times 340 times cosine of 151.5 degrees. Now I've worked that out on the calculator. On the calculator, that comes out to be B squared equals 528,714. That's B squared. Now I take the square root of that to get B, and rounding to 3 significant digits, I get 727 meters. So that's side B, 727 meters using the law of cosines. So I use the law of cosines to solve for side B. Now I have side B, the angle opposite. I can solve for either one of these two angles right here. Since I have a choice of which angles to solve for using the law of sines, let's use the law of sines to solve for angle C first. So using the law of sines, I'm going to have sine C, which is what I'm looking for, is to side C, 340, as the sine of 151.5 degrees is to 727. So I set up my law of sines that way. Solve for sine C. And I won't show you the work right here. I put this on the calculator and get approximately 0.2232. Using my inverse sine button on the calculator, that tells me that angle C must be equal to 12.9 degrees. So 12.9 degrees. I don't have to check for an angle C prime like I would in the ambiguous case because I already have an angle in this triangle that's bigger than 90 degrees. So I'm not going to have another obtuse angle, so there's no need to say 180 minus 12.9 degrees. This is angle C. So angle C is equal to that. Last thing I have to do is find angle, what is it, A? And angle A will be 180 degrees minus 151.5 degrees plus my 12.9 degrees. And I've already worked that out also, and that comes out to be 15.6. That's angle A. So law of cosines first, because I have an angle and the two sides included on either side of the angle. And so I use my law of cosines to find the side opposite that. Then I switch over to the law of sines to find my next angle. Once I have that, I just subtract the two angles I already have from 180 degrees, and I have my third angle. And that triangle then is solved completely. Let's go to our next problem. If A is 38 meters, B is 10 meters, and C is 31 meters, let's find the largest angle. Well, let's draw a little picture right here just to help us out. We have A, B, and C for my angles. Let's see, I'll label side A with 38. I'll label side B with 10. And I'll label side C with 31. Now, when I look at my diagram right here, I know that the largest angle is opposite the longest side. So I see my longest side is 38, so my largest angle is going to be angle A. And remember, this is not drawn to scale. I've just drawn this triangle so I have something to label. So I'm going to solve for angle A first using the law of cosines, and the law of cosines tells me this. Cosine of angle A will be B squared plus C squared minus a squared, all divided by 2bc. So according to the law of cosines, I can write the law of cosines that way to solve for angle A. Let's substitute in now, and I'll have, let's see, 10 squared plus 31 squared minus 38 squared, all divided by 2 times 10 times 31. I've worked that out on a calculator. That comes out to be negative 0.6177, negative 0.6177, and that implies that when I use my inverse cosine button on my calculator, that angle, whoops, not B, but angle A, comes out to be 128 degrees. So, pretty simple, using the law of cosines to find the largest angle in this triangle. It's going to be opposite the longest side. Here's my law of cosines, that formula for cosine of A. Substituting these values, get out this decimal right here, inverse cosine button on the calculator, A is equal to 128 degrees, rounded to the nearest degree, so I have my significant figures right here. That's a look at the law of cosines.